The story of fire hydrants is deeply woven into the broader narrative of urban safety, engineering innovation, and the persistent human effort to combat one of nature's most destructive forces, fire. What we know today as the modern fire hydrant has evolved significantly over the centuries, from primitive methods of water access to sophisticated, standardized systems found in nearly every developed community. This evolution was not only shaped by technological advances but also by catastrophic fire events that reshaped cities and led to stricter fire safety policies. Understanding the history and design evolution of fire hydrants offers insight into how societies have adapted to urban growth, climate, and risk, all while refining the tools available to first responders. Long before the invention of fire hydrants, civilizations developed rudimentary ways to combat fires. In ancient Rome, aqueducts supplied water to public fountains and basins, which could be used by citizens in emergencies. During the medieval period in Europe, bucket brigades were the only option, requiring citizens to pass buckets of water hand to hand to suppress fires. As cities grew denser and more prone to catastrophic blazes, such as the Great Fire of London in 1666, the need for a better water distribution and access method became undeniable. Early attempts included tapping into wooden water mains by drilling holes and inserting metal fittings to draw water, which led to what is considered the earliest prototype of the fire hydrant. The first official patent for a fire hydrant is credited to Frederick Graff Sr., a hydraulic engineer with the Philadelphia Water Works, in 1801. Graff designed a post-type hydrant with a valve at the base, which could be opened with a special wrench to release water. It had a removable plug and allowed firefighters to connect hoses quickly. Though no physical patent record survives, reportedly destroyed in a fire, it remains a foundational invention in fire protection history. Graff's design led to what we now refer to as the wet barrel hydrant, primarily used in warmer climates where water can remain in the barrel year-round without the risk of freezing. However, as fire protection needs grew in colder regions, the dry barrel hydrant was developed. This design features a valve located underground, below the frost line. When closed, the barrel remains dry, and water is only allowed to enter the hydrant when the valve is opened. After use, a drain valve allows residual water to escape, preventing freeze damage. This improvement was crucial in northern cities and remains the standard in cold climates to this day. The basic form of the dry barrel hydrant hasn't changed much since the 19th century, though materials, internal mechanisms, and durability have vastly improved. As urban infrastructure expanded through the 19th and 20th centuries, fire hydrants became not just essential for safety but also standardized by municipalities and organizations such as the National Fire Protection Association, NFPA. Standards like NFPA 24 and 291 were developed to govern the installation, spacing, flow rates, and color coding of hydrants. These standards also addressed factors such as residual pressure and hydrant location accessibility, ensuring that firefighters could rely on consistency across jurisdictions. In many regions, color codes were adopted to indicate hydrant flow capacity, often red for low flow, orange for medium, and green or blue for high flow, so fire departments could quickly assess performance during emergencies. Design-wise, modern hydrants have seen significant improvements. Early hydrants were made primarily of cast iron with brass or bronze internal components. Today's hydrants utilize corrosion-resistant alloys, epoxy coatings, and improved valve seat materials to extend operational life and reduce maintenance. Breakaway flanges were introduced to minimize damage in case a hydrant is struck by a vehicle, allowing for easier repairs. Some models include anti-tamper features and locking mechanisms to prevent unauthorized access, while others integrate smart sensors to monitor pressure, water theft, or leaks in real time, part of the growing smart city infrastructure movement. Fire hydrants have also evolved in terms of functionality beyond firefighting. They are often used for flushing water mains, temporary water service connections, street cleaning, and even filling water tenders in rural or wildfire-prone regions. In emergency response planning, hydrants are critical nodes on water grids, and GIS-based mapping systems now track hydrant locations, testing history, and maintenance schedules. This allows fire departments to plan tactical operations and monitor system readiness with greater accuracy. One fascinating aspect of hydrant history is the regional design diversity. For example, in the United States, hydrants are usually above ground with prominent hose outlets, while in many parts of Europe and Asia, underground hydrants are more common to avoid clutter in narrow streets or public areas. These underground hydrants require a separate hydrant standpipe and wrench for access, making them less vulnerable to vandalism or damage but slower to deploy in an emergency. Cultural and climatic considerations have played a major role in shaping hydrant design and placement across the world. Hydrant evolution also mirrors key moments in urban firefighting history. The Great Chicago Fire of 1871, which destroyed over 3 square miles of the city, prompted a re-evaluation of water supply systems and fire protection measures. In response, many cities overhauled their infrastructure, creating better grid layouts, increasing hydrant density, and investing in centralized fire pump stations. In more recent history, wildfires in California, Greece, and Australia have highlighted the limitations of traditional hydrants in large-scale emergencies, spurring innovation in mobile water supply solutions and hybrid hydrant systems with foam or chemical agent capabilities. Maintenance has always been a central concern in hydrant effectiveness. Municipalities around the world implement annual or biannual inspection routines where hydrants are flushed, lubricated, flow-tested, and visually checked for defects. Inadequate maintenance can result in hydrants being frozen, clogged, or inoperable during an emergency, a situation that has led to tragic losses in the past. Increasingly, municipalities are digitizing these inspections, using barcodes or RFID tags to track each hydrant's history, while some modern models incorporate pressure gauges and flow meters built directly into the hydrant body. Looking to the future, the evolution of fire hydrants is likely to continue in parallel with advances in sensor technology, urban planning, and climate resilience strategies. Smart hydrants with IoT, Internet of Things, integration are already in deployment in pilot cities, capable of detecting unauthorized use, leaks, or sudden pressure changes that may indicate a burst pipe or fire. These hydrants can send real-time alerts to utility managers and fire departments, improving both resource conservation and response readiness. Additionally, 3D printed hydrant parts and modular hydrant designs are being explored for faster repairs and lower costs in developing regions. Despite the modernization, the symbolism and visibility of fire hydrants remain constant. They are iconic elements of city landscapes, often painted in bright colors or even artistically customized in some communities. More than mere hardware, hydrants represent a city's commitment to safety, preparedness, and community well-being. In fact, their very presence influences building codes, insurance ratings, and fire department deployment strategies. A building without adequate hydrant access may be considered non-compliant or face higher premiums due to the increased risk factor. In conclusion, the fire hydrant has undergone a remarkable transformation from crude water access methods to sophisticated and integrated components of urban infrastructure. Its design evolution reflects centuries of learning, driven by the consequences of fire disasters, technological innovation, and public policy. Fire hydrants today are not only firefighting tools but also components of smart cities, community safety assurance, and civil engineering pride. Whether installed in a bustling metropolis or a quiet rural town, each hydrant is a testament to the enduring human pursuit of safety, resilience, and progress in the face of one of humanity's oldest adversaries.